All right, this problem is going to take a little bit of time. You may need to pause as I go through this problem with you. So just feel free to pause as needed. I am going to go through the problem very quickly, so pause when necessary. In a Hess's law problem, you're going to be given an overall reaction, and you're going to be asked to determine the standard enthalpy change for that entire reaction by putting together different reactions. I'm first going to start by flipping the first reaction, and the reason I'm going to flip it is notice it has carbon solid, which I need in my final reaction, but it's on the wrong side. Also, I need two of them instead of one. So since I need carbon on the right side, not the left, and I need two of them, I'm going to flip it and multiply it by 2. So notice I've flipped the reaction. I have CO and H2 on the left side and C and H2O on the right, but I've also multiplied it by 2, and therefore I have to reverse the sign of my delta H. So it's negative 131.3, and I have to multiply it by 2. Now I'm going to take a look at the second reaction. And the second reaction is kind of interesting. We do need to flip this reaction because if you notice, we do need CO2. This is the only reaction that includes carbon dioxide. And I do need it on the other side of the reaction. I do have the right number of it, so I am simply going to flip this reaction so that the carbon dioxide and hydrogen are on the reactant side. Again, that's the side I need them on for my final reaction. There's my carbon dioxide right up there. So I flip the reaction, and what that does is it makes my delta H positive instead of negative. In my final reaction, notice CH4 is in the correct location. It has the correct number of moles of it, so I'm going to leave it alone. So I'm going to leave this reaction as CH4 plus H2O yields 3H2 plus CO. And my delta H is going to stay 206.1. Now I'm going to start canceling out substances that appear on both the left side. Notice I have 2 COs on the left, 2 COs on the right. 3 hydrogens on the left, a 3 hydrogen on the right. I'm also going to get rid of one of my waters, and I'm left with CH4, CO2, 2 C's, and 2 H2O's. When I put that all together, CO2 plus CH4 yields 2C plus 2H2O. It is the exact reaction we were looking for. And now to find my delta H overall, I simply add it all together. Negative 262 plus 41.2 plus 206.1, and my overall delta H for this reaction is negative 15.3, and the way we write the unit, kilojoules per mole reaction. Again, feel free to start this over and pause it at the beginning, try it on your own, or pause as I'm going through it to make sure you're understanding all of the steps.